Getting an original IBM PC or XT nowadays onto Ethernet is harder than it sounds. Most ISA network cards available today were made for the 16-bit bus, and surviving 8-bit cards are rare and expensive. But this modern open source reproduction changes that. It is an NE2000 compatible 8-bit ISA Ethernet card for early PCs. Let's have a look at it and see how it compares to other contemporary 8-bit Ethernet cards.
Let's talk about legacy network technology. I'm the Vintage Collector and these are my stories.
This Ethernet adapter was designed by Sergey Kislev in 2021 and released as an open source hardware design. It is meant for early PC compatible machines, including the original IBM PC and IBM PC XT, where you only have the original 8-bit bus. And it is NE2000 compatible. That is important because NE2000 became one of the great common denominators of PC networking. It started with Novell, originally as a way to make Ethernet hardware cheaper and more widely available for network systems. But the design was copied so often that NE2000 compatible became a de facto standard. By the 1990s, most network operating systems supported NE2000 style cards out of the box. So even for a modern reproduction, this is a very practical target. As mentioned, this is completely open source, so you can fabricate it even yourself. Alternatively, a fully assembled one can be yours for just $60. This spares you from hunting down original 8-bit Ethernet cards, unless, of course, you really want the original experience. But let's put this one now to the test. For testing it, I'm using my homegrown DOS TCP IP diagnostics disks. You have seen those in a previous episode. Since then, I added more drivers, cleaned up the startup scripts and even created a 360K disk set. That one has not seen much testing yet, so today is a good excuse. There is one important catch with this card. Even though it is NE2000 compatible, the standard Crinware NE2000 packet driver does not work with it. You need the patched NE2000 packet driver instead. Normally, my disks load the NE2000 driver automatically, but for this test I skipped the autoloading and configured it manually, and here we run into a classic IBM PC limitation. On later 16-bit ISA machines, I usually default to IRQ10 and I address to 300 hex for network cards. But the IBM PC and PC XT only have IRQs 0 through 7. There's no IRQ10 here. So I changed the setup to IRQ2, which is what I configured on this card. At least that was the plan. The driver loaded, but the card only reported FFs as its MAC address. So something was clearly not right. Next I tried Realtek's RZ8019 utility. Since this card uses an RTL8019 controller, the original Realtek setup should work. But on this IBM PC, with its limited RAM, the utility would not even start. So instead of moving the card to another machine just to configure it, I simply switched it from software configuration to jumper configuration mode. Being pragmatic, that was good enough. And while the case was open, I fixed one small leftover from my IBM PC Restoration Journey 2022. This mystery hole above the keyboard and cassette ports is normally covered by a plastic plug. Mine was missing, so a 3D printed replacement finally closes it again. Some third-party expansion cards like the AST Mega Plus 2 actually use this opening for extra connectors, but here it is just a cosmetic fix. Back to the network card. After switching to jumper configuration mode, the patched packet driver loaded correctly. My boot disk also uses a packet driver multiplexer, so I can run the Trumpet TCP TSR as an ICMP responder. That way, the IBM PC can answer ingress ping requests. And indeed, the IBM PC was responding to pings from a Mac. But the PC definitely ran into an out-of-memory condition and stalled at the terminal. So I adapted my startup script to check available memory first, and on systems with less than 512K, skip loading the Trumpet TCP TSR. Fun fact, this quick edit accidentally turned into a very modern meets vintage moment. I opened AUTOEXEC.BAT in Visual Studio Code, added the checkmem512 line, and the AI coding assistant immediately suggested the rest of the batch logic. All I had to do was to press tab. I only changed the error message afterwards to make it a little bit more precise. So yes, completely unplanned, I ended up using an AI coding assistant to change a DOS batch file. I honestly did not expect that one to work. But in the end, the small change did the trick to not run out of memory. Now, how does the open source card compare to true historic 8-bit Ethernet cards? That was what I wanted to find out. I was lucky and found these two cards in a clearance sale a while ago, a 3-COM Etherlink II from 1989 and this much larger InterLAN NI5010. I did not find the original release date for the InterLAN card, but the PC IP Users Guide from March 1986 already mentions it, so sometime around 1985 is probably a fair assumption. First, I installed the Etherlink II into the IBM PC XT5160. No big surprise here. Set the correct jumpers for IRQ and I address, put it into the machine and boot DOS. Unlike the reproduction card, this one does not support twisted pair Ethernet. It has AUI and BNC connectors, so I brought back one of my old combo hubs, which can bridge between twisted pair and RJ58 coax wiring.
Wait a second, shouldn't there be a terminator?
Not in this case. This hub has built-in termination for the BNC side, enabled by this switch so the cable can go directly into the hub. Back in DOS, I ran the diagnostics utility and the card reported all good. And as expected, ping worked as well. My disks also include Packet Tool, which listens on the network and dumps some basic network traffic on screen. Here it mostly shows ARP requests from the network. I also wanted to run M. Brotman's speed test utility for a quick benchmark, but on this 256K machine it failed while initializing TCP buffers. So unfortunately, no direct benchmark today between the IBM PC with the reproduction card and the PC XT with the Etherlink II. Realistically, we probably would have seen something around 50 to 100 kilobytes per second, judging from similar systems. But for a proper comparison, I would rather test a real client-server setup anyway, maybe with Novell NetWare, Lantastic or something similar. Let's leave that for another episode. Next, let's have a look at the InterLAN NI5010 card. For that, I opened up the IBM PC 5150 again and replaced the open source Ethernet card with the InterLAN card. This one was slightly more confusing to set up. There is a very useful jumper guide available, but the manual describes these settings as positions 1-2 and 2-3. This is fine in principle, except my card itself does not label the jumper positions that way. It only marks them as A and B. So I assumed A means 1-2 and B means 2-3. Besides IRQ and I address, this card also needs jumpers for selecting either the AUI port or the onboard transceiver for direct RJ58 coax attachment. So there is a bit more to check than on the Etherlink II. But luckily my jumper assumption was correct. Since I had never tested this card before, I was honestly relieved to see it working after roughly 40 years. And if you're wondering why I swapped the two network cards in the IBM PC, then stay tuned for next Sunday, where I'm going to put the open source card into the IBM PC Portable 5155 and maybe even try booting it with Linux. In the meantime, tell me your approach to vintage networking. Are you on Team Aftermarket Nick or on Team Original only? Share your practical experience and shenanigans in the comments below. And if you enjoy stories like this, please consider subscribing. It really helps the channel. And if you want to support the work even more directly, you can also become a channel member and benefit from early access to new videos. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.